So, first feature here of recording on YouTube. Another one here, limited in excess. We're given the quantities, the mass in grams of sodium dichromate, which is this here, Na2Cr2O7. A lot of the times you see sodium dichromate and potassium dichromate, they just put in the wee charges up there. 18.4 grams of ethanol, which is this here. So this is oxidation of a primary alcohol to give an aldehyde, PAC. It's incomplete. There isn't an excess going all the way to the carboxylic acid. It's just stopping here at the aldehyde stage. We'll show you one next where it goes all the way to ethanoic acid. And what you've got to do is find the maximum amount of ethanal formed, the aldehyde formed here. So the first thing what I would do, write down the ratio in which they react. So it's 3 to 1 to 8. That's just my acidified sodium dichromate. You can see the H plus, 3 to 7. Now work out the number of moles of each of the reactants. I'll just write sodium dichromate as Na2Cr2O7 because we need to write it like this in order to get the relative molecular mass. Now generally in exam papers they will show the formula, like sodium thiosulfate, pentahydrate sodium thiosulfate, they'll show in the 5H2O in your redox titrations. So working out the relative molecular mass of this, 2 by 23. Chromium is 52. It's 262. Now, the relative molecular mass, it's 29.8 grams. Again, you're just using this part of the mole triangle, mass in grams divided by relative molecular mass. Bring you back to the moles. Gives you 0.1137 moles. Now work for your ethanol, your primary alcohol here. I'm just writing 6 by 1. You have 5 hydrogens here and 1 here. So that's 30, 46. We have 18.4 grams. Divide that by 46. 2/5 or 0.4. Now again, we cannot automatically assume that this is an excess. You've got to look at the ratio, and the 0.4 links to here, or sorry, for here. Well, your 0.1137 links to this. So I can either divide this by 3. I'm going to do that. I get 0.133, which is actually more than this. So this is an excess. Alternatively, you could, this is the number of moles sodium dichromate, multiply this by 3, and it should be less than 0.4. Just to show you that, 0.1137 by 3 gives us that, which is less than 0.4. So this is our limiting, and this is the one that you always work with. Always work with the limiting. It dictates the amount of product formed. So now fill the limiting back into the equation and alter it according to the ratio. So 0.1137 is here. And then to work out your ethanol, and I'll multiply by 3. 0.3411. And you could multiply by 8 and by 2 and by 7. Multiply this one by 8, 2 and 7. But I was looking at the question. It says find the maximum amount of ethanal that is formed. There's your ethanol. So that's all I need to know for the number of moles. So max amount of ethanol. This is known as our theoretical yield. We'll show you now in the next one. Looking at percentage yields. So max amount formed. The number of moles to go to mass in grams multiplied by the relative molecular mass. So 0.1137 multiplied by the relative molecular mass of ethanal. So 1 by 12. Again, we've got 4 hydrogens. We have another 12, so I could have put it in up there. And we have an oxygen. 24, 40, 44. And it gives us 5.00, so we'll just write 5 grams.